So this is a tutorial session where we are going to solve some problems on gears. There are around 15 problems here. So this is your first problem. It says here we have a spare gear pair operates at a center distance of 150 millimeter, right? So we have the center distance as 150 millimeter. The speed reduction is 4:1. This speed reduction is the gear ratio, if you remember. The gear ratio here is 4:1. So we have the center distance as 150 millimeter. We have the speed reduction or the gear ratio as 4:1. And the pinion has 20 teeth. So the number of teeth on the pinion are 20. We have 20 degrees pressure angle. Determine the module. So the module, this small m value is required here. Okay. So what we can do, just think straight away about the definition of the module and how the module and the center distance are linked. So what is given here? We have the center distance, 150 millimeter. We have the gear ratio as 4. We have here the number of teeth on the pinion, 20. We have the pressure angle as 20. Okay, so here is the equation that links the center distance to the module to the number of teeth, right? So first, the center distance CD is equal to M over 2, which is the module over 2, multiplied by T, which is the number of teeth on the pinion, plus the number of teeth on the gear, right? So the center distance is given as 150. The module is unknown. And then the number of teeth on the pinion is 20, but the number of teeth on the gear is 80. How did you find this one? So the gear ratio is equal to capital D divided by small d, and it is equal to 4. So capital D divided by 20 is equal to 4, and then capital D is equal to 20 times 4, which is 80. So from here, we can find that the module is equal to 3 millimeter, okay? Second problem that you see here, we have a pair of gears with a gear ratio of 2 to 1. So the gear ratio here is 2 to 1, okay, or 2. We have a center distance of 5 inch, 5 inch, okay? And then we have a diametral pitch. So we have a diametral pitch here of 6. So this diametral pitch, if you remember, its diametral pitch is equal to the number of teeth over the diameter for the pinion, or the number of teeth over the diameter for the gear, okay? And D, small d or capital D must be in inch here. That's why the center distance is given in inch. So determine the number of teeth on each gear, okay? So what we have here, we have the center distance is given as 5 inch. The gear ratio is given as 2 to 1. The diametral pitch is given as 6, okay? So what we need to do here in order to find the number of teeth, okay? So again, remember the definition of the center distance, okay? So the definition of the center distance can solve the problem. So the gear ratio is 2 to 1. Then again, so the gear ratio is equal to capital D over small d is equal to 2, okay? From here, we can say capital D is equal to 2 times small d. So this is the first step. The second step, this is coming, of course, from the gear ratio. The second step is that the definition of the center distance itself is equal to, if I just go back, so the center distance is equal to the radius of the pinion plus the radius of the gear, okay, of the pitch circle. So in this case here, so the center distance is equal to capital D plus small d over 2. And then from here, the center distance is given as 5 inch, okay? If you multiply by 2, so it gives you 10 inch, and then you have capital D plus D here, but remember that we have another relation here that capital D is equal to D. So from here, we can simply find from this equation, we can simply say that small d is equal to 10 over 3 inch, okay? Then, of course, the value for capital D can be found as well. But here, remember the definition of the diametral pitch. So the diametral pitch is equal to the number of teeth for the pinion divided by the diameter of the pitch circle of the pinion. So the diametral pitch is given in this case, it is 6, right? So, so in here, from this equation, we can find T, which is the number of teeth on the pinion. So the number of teeth on the pinion is equal to 6 multiplied by the diameter, D, which is 10 over 3. So this is around 20 teeth. Remember that the gear ratio is equal to capital T over small t, right? And this is equal to 2. So if we know that small t is 20, so it means that capital T here is 40. Okay, so let's move on to problem number 3 then. So we have here, we have a spare gear, and this spare gear has a module of 3 millimeters. So the module is given here. Calculate the thickness of the gear tooth, measured along the pitch circle. Okay, so look at this graph here. So this is the pitch circle, okay? And then if you measure the circular distance from one point on this tooth to the corresponding point on the next tooth along the pitch circle, so this gives you the circular pitch, right? And then if you measure this distance from here, from this point to this point along the pitch circle, this gives you the thickness of the tooth, right? So there is a relation between these two. So the tooth thickness is equal to half of the circular pitch, right? So it's kind of problematic here because we have only the module. How we can find, for example, in order to find the tooth thickness, we need to find the circular pitch. Is there any relation between the circular pitch and the module? The module is equal to D over T, or capital D over capital T, right? What is the circular pitch? By D over T, or by D over T, right? Is there a relation between these two? So it just means that we can take the module here, which is 3, multiplied by pi. It's gonna give us PC, right? Once we have PC, we can go to this equation, divide PC by 2, and then we get the thickness of the tooth, right? Now this is the solution of the problem. So the module is 3, and then the answer is as follows. So we know that the module is capital D over capital T, or small d over small t, and then the circular pitch is pi d over t, or pi small d over small t. And then we know that the circular pitch is equal to pi multiplied by the module, which is 9.42, because the module is given as 3. Then the thickness of the tooth is equal to the circular pitch divided by 2, which is going to be 4.7. Okay, good. So next problem. So we have here a pair of a pair of spare gears provides a given speed ratio at the specified center distance. So the center distance is given here as 7.5 inch, and I have a diametral pitch of 8. So the diametral pitch here, PP, is equal to 8. Okay. Determine the number of teeth and the pitch diameters of the gears. Okay. So the number of teeth, small t, capital T, and also small d and capital D are required. Okay. So what we have here, we have the gear ratio, remember? We have the diametral pitch, we have the center distance, and then small t, capital T, small d, capital D are required. So the thing is that we can relate the center distance to the diameters, right? And then based on the gear ratio, we can relate the gear ratio to the diameter. So we have 2 equations into unknowns, and then once we solve these 2 equations, we have the diameters. And because we have the diametral pitch, so we have a relation between the diameter and the number of teeth, right? So here, what we have the center distance, we have the gear ratio, and we have the diametral pitch. So we're going to do the following. So the center distance is capital D plus small d over 2, the radius of the pinion plus the radius of the gear. This is given as 7.5. So from this equation here, we say that capital D plus small d is equal to 17, and this is your first equation. And then based on the gear ratio, we know that the gear ratio is equal to capital D over small d, which is 4, right? So, and then capital D is equal to 4D, and this is your second equation. You just need to solve these two equations simultaneously. Once you solve these two equations, you have the diameter here of the pinion as 3 and the diameter of the gear as 12, right? Then in order to find the number of teeth for both pinion and gear, so we can use the definition of the diametral pitch. So the diametral pitch is equal to capital T over capital D, or small t over small d, right? Then we have capital D, we have small d, we have the diametral pitch. So we can just, these are two equations. We can use diametral pitch with the first portion to find capital T, and then we can use the diametral pitch with the second part to find small t, okay? So the diametral pitch is 8. If we use it with the second part, so 8 is equal to T over D. Okay, so it's equal to T over 3. So from here, T is equal to 24 teeth, small t. So then 8 again is equal to capital T, which is the number of teeth on the gear, divided by capital D, which is the pitch diameter of the gear, is equal to here is the problem again. So we have a pinion with a module of 2 millimeter and 24 teeth. It rotates at 2400 RPM, which is a small omega here. And it drives a gear with 800 RPM, capital omega. Then determine the number of teeth on the wheel, which is T. And then the circular pitch, P sub C, and the theoretical center distance, CD. So we have the module, right? If we multiply this module 2 by pi, so it's going to give us the circular pitch straight away, right? Okay, good. So what we have here, first, we have the gear ratio because we have a small omega and the other omega. So we have 2400 over 800. So the gear ratio is 3, okay? Remember that T, small t, is given as 24. And we understand that the gear ratio is equal to capital T over small t, right? So this is equal to 3. So this means that the number of teeth on the gear is 24 times 3, which is 72, okay? Then, as I said, the circular pitch is pi multiplied by m. So it is, m here is 2, so it's 2 pi, right? Then we can find because we know the number of teeth, we know the module, so we can find the diameters. So the pitch circuit diameter of the pinion, D is equal to M times T. M is given as 2. The number of teeth here is 24. So we have the diameter for the pinion. Capital D is equal to M times T. The module is given as 2, and the number of teeth 72. So we have this diameter as well. And then remember the center distance is equal to capital D plus small d over 2, right? So we can use this equation to find the center distance or the theoretical center distance. So we have here, again, a pair of involute gears of known base circles. So the diameter of the base circle of the pinion is 60 millimeter. The diameter of the base circle of the gear is 120 millimeter, right? So the base circle here is the dashed one, is the one in the inside circle. And the outside circle is the pitch circle. So this is the pitch circle. And the inside one here is the base circle. I hope that you know the difference between them now. The distance from here to here is the center distance, and the pressure angle is phi, okay? And there is a relation between capital R, RB, and small r and RB. Okay, so R is equal to R cosine, and P is equal to R cosine. Right, so what we have here, we have the base circles are given. The center distance, we have two cases, case A and case B. The center distance for case A is given as 120, so the center distance is 120. And for case B, the center distance is 100. So we are just gonna solve the problem as first, if the center distance is 120 millimeter, and then we're going to solve the same problem if the center distance is 100. Determine the pressure angle. So we need to determine for each case, we need to find pressure angle phi, okay? And for each case, and also the gear ratio. So we need to find the gear ratio for each case as well, okay? So the data is given as the base circuits, okay? So how we are gonna solve this? Let's focus on case one first, which is the center distance is 120, okay? So as I said, there is a relation between the radius of the pitch circle and the radius of the base circle, okay? So this is for the pinion and this is for the gear, okay? So, and we know also that the center distance is small r plus capital R, which is the radius of the pitch circle of the pinion and the radius of the pitch circle of the gear. And in the first case, the center distance is equal to 120. So based on this relation here, we can substitute these values here. So we substitute small r by RB over cosine phi, and then we substitute capital R by RB over cosine phi. The base circle radius of the pinion is 30, the base circle radius of the gear is 60. Then from this equation, we can solve for the pressure angle phi. So where phi here is 41.4 degree. Right, so this is the first case. For the second case, we're gonna do the same. The only difference is that the center distance is 100. So exactly the same procedure. But here the center distance is 100. So we have 30 over cosine for the pinion, 60. So this is small r, this is capital R. And then in this case, when we use the 100 millimeter center distance, we are getting here a pressure angle of 25.8. So for the gear ratio for both case A and B, so the gear ratio actually is equal to D over D, capital D over D. But we know that there is a relation between the base circle diameter and the pitch circle diameter for both the pinion and the gear. So they have the same ratio, okay? Because cosine phi is the same, okay? So dP equals D cosine phi, right? And then dP is equal to D cosine phi. Okay, so if you just divide these two, it's going to give you the same ratio, D over D. So dP over dP is equal. So it's the same ratio. So we know the diameter, the base circuit diameter for the gear, the base circuit diameter for the pinion are given. So the ratio is going to be 2. So it just means one thing here is that regardless of the center distance value, so the gear ratio does not change, because for case one, the dP, capital dP and small dP are the same for both cases. We did not change them. So it means that the gear ratio is going to be fixed. So it means that in this case, changing or any error in the center distance does not change or does not affect the gear ratio, which is a very important feature for this involute curve profile. This problem you're going to solve yourself at some point, but I'm going to give you some tips here. It is something to think about. It's not a task, it's not an assignment, it's just something to think about. So we have a gearbox is required with an overall speed reduction of 25:1. So the gear ratio here is given as 25:1. Specify a suitable external spare gear. So the ones that we have been studying so far are called external spare gears. Sometimes they call them set of gears, including the speed ratios, number of teeth. So these are the things that are required to be identified. The speed ratios, the number of teeth, the module, addendum, dedendum, etc. Okay. There are some limitations here on the height of the gearbox, which is 320 millimeter. The spare gears are of standard form. Standard form, remember that the phi has to be 20 degrees. The addendum is equal to module. The dedendum is equal to 1.25 the module, etc. These are the values that we use, and we use also a standard value for the module. So in this case, there are a variety of options here. It's not like a one solution. There is a large number of suitable designs here in this problem, but it is quite important to remember 2 points. The first point is that the maximum gear ratio for spare gears is 8:1, and the minimum number of pinion gear to avoid interference is greater than 17. So this means that we can assume it around 20. Then also here we can use what's called double reduction gearbox or gear train with 5:1 each. I'm just gonna draw a small graph here. Maybe it will be easier. So if you, for example, have an input shaft here, okay, and this is the pinion, okay. This pinion is engaged with another gear here, which is the gear. So, and then let's say we have another shaft. So what I'm going to say is that this is the input shaft. If this is the input shaft, and this is the output shaft, okay, then you have here pinion, and then you have here gear, okay, and then you have intermediate shaft here, okay, then you have another driver here that is going to drive this, okay. So you have gear number 1, gear number 2, gear number 3, gear number 4. So what you see on the screen here, guys, is called double reduction gear train. Why? Because you have 2 stages here. You have one stage here, and you have another stage here. So you have 2 stage or double reduction gear. So the gear ratio here for this part can be assumed as 5. And then the gear ratio for this part can be assumed as 5. When you multiply these 2 together, they give you 25, which is what is in here. This is explanation of the latest statement here. In this case, this is the pinion, so the minimum number of teeth could be 20 here, and then based on the gear ratio, you can find the number of teeth on the gear number 2. Then again, this is a driver. This is intermediate shaft, and then this gear here drives this one. So this is the driver. Number 3 is the driver. So in this case, you can consider this as a pinion again, and the number of teeth, the minimum number of teeth to avoid interference is 20. And then again, based on the gear ratio of this stage, so let's say this is gear ratio 1, this is gear ratio 2 for stage 2, and then, so you can just draw something like this. We want you to think about it. One more thing is that the omega 2 is equal to omega 3. Why? Because actually they are on the same shaft. Okay, good. So the next problem number 8. So again, similar to the previous one, this is a bit easier. It says sketch a spare gear pair of approximately 2:1 reduction, right? So show on your drawing the pitch point, the base circle, the outside diameter, the pressure angle, line of action. So go back to what you have seen so far, and then try to sketch the 2 gears, or this pair of gears, and then indicate also the points of first and last contact, and just write down the equation of the length of contact, LAB. Okay, You can do the same for a rack and a pinion as well. Yeah, you just need to do some research on this to find the length of contact for a rack and pinion. So in here, in this problem, it says a gear has an addendum diameter of 80 millimeter. So you see here that if we consider the one that is underneath here is our gear. So we have here the outside diameter of the gear is 80, or sometimes they call it the addendum diameter, right? We have full depth involute teeth with a module of 2 millimeters. So the module is given, and the pressure angle is given as well as 20 degrees. Determine the pitch diameter of the gear. Determine the circular pitch, which is P sub C. Here, D is required. The addendum value, so this is A. The addendum value, which is B. If we consider this is gear, not the pinion, so I'm just using the capital letters. And the number of teeth on the gear as well, capital T. So what we have here, So we have the external diameter, which is the addendum diameter. We have the module, and for standard proportions, we can just simply say the addendum is equal to 1 multiplied by the module, and then the addendum is equal to 1.25 times the module, and of course the phi, or the pressure angle, is 20. Right, so for the tooth proportions, if we use the standard tooth proportions, standard values, addendum is 1 times the module, the addendum is 1.25 times the module. The diameter, because if this is the external diameter, okay, and then we have here the pitch circle, okay, and here is the center. So the distance from here to here is the R sub A, which is the radius of the addendum circle, and the distance from here to here is capital R, which is the pitch circle, right? There is a relation between them. You see, if you consider the diameter, so the diameter, which is 2 multiplied by R, of course, is equal to 2 multiplied by RA minus 2A. The distance between here to here is called the addendum, okay? That's why we're just subtracting 2A from this diameter. So the diameter from here to here is called D sub A, okay? And then the diameter from here to here is called D, capital D. And then this distance is A, and this distance is A, okay? So from here we can find the diameter, and this nice relation. Once we know the module, we can find the circular pitch. Circular pitch is equal to pi times the module, which is 6.25. The number of teeth, simply the number of teeth can be found because we know the diameter and we know the module. So the diameter here, the pitch circle diameter is 76. If you divide this by the module, it gives you the number of teeth. So we have a pinion of 16 teeth, okay? It drives a wheel with 50 teeth. So the number of teeth, small t, capital T, are given. The RBM here for the gear is given as well as 800. The pressure angle phi is given as 20. And the module here is given as 10 millimeter. If the addendum is 12 millimeter, remember for the pinion, so this is small a, and 8 millimeter for the gear. So this is, or the wheel. So this is capital A. So calculate the maximum velocity of sliding, the arc of contact. So this is the maximum velocity of sliding, if you remember, the arc of contact and the contact ratio. So the contact ratio is CR, and the arc of contact, which is QR. So first, here are the data. So we have small t, capital T, we have capital omega for the gear, we have the module, we have the gear ratio, the pressure angle, we have the addendum for both the pinion and the gear, okay? So we need to find the maximum velocity of sliding, the arc of contact, and the contact ratio. Okay, so if you remember, we're going to go through some of those figures that with the triangles, the red one and the blue one, etc. So to find the maximum velocity, we need to find both omega and capital omega, small omega, and we need to find the value PC, if you remember. So this is the equation that you need to use in order to find the sliding velocity or the maximum sliding velocity. Okay, so the velocity of the pinion can be found using this gear ratio equation. We know that capital T is given, small t is given, this capital omega is given, so we can find the velocity or the rotational velocity of the pinion, which is 2,500 RPM. Okay. Then using the module relation here, we can find the diameters for both the pitch circle of the pinion and the pitch circle of the gear, right? The module is given 10. The number of teeth here is given as 16. The number of teeth here are given as 50, and the module is given as 10. So using this relation, we can find the small r and capital R, which are the pitch circle radii for both the pinion and the gear. Okay, we need these. We need also the base circle radii. So we understand that there is a relation between these two. There's a relation between these two, remember? So R sub B, which is the base circle, is equal to R cosine phi. Okay, so the R value here, which is the radius of the pinion, is 80. The angle, the pressure angle is 20. So we can find the base circle radius for the pinion. We can find again the radius of the base circle for the gear. So this value is 250 multiplied by cosine 20. So we get the radii or the base circle radii for both pinion and gear. So we need these four values in order to calculate the length AB, actually. Okay, so we can find also these values, the addendum radii, if you remember. So the addendum radii RA is equal to R plus the addendum. Again, if you draw a circle here, so this is the external circle, this is the pitch circle, and then this value here is RA, this value is R. And the difference between them here is small a, which is the addendum. The same for the gear, RA is equal to R plus capital A, which is the addendum. The addendum is given for both the pinion and the gear. So for the pinion, it's given as 12. So if you add 80 to 12, so it gives you 92. And here for the gear, it's given as 8. So if you add 8 to 25, it gives you 258. If you add 250 to 8, it gives you 258. So remember this graph before. We have point A star, B star, point A, point B, then point P. And then we have the relation between them. We don't need to do this again, but this is the equation for the distance AB. So from A to P, from here to here, this is the equation. And then we have another equation for the distance between P to P. Then you can calculate this value based on the radius of, the radius of addendum circle, the radius of the pitch circle, and the value for of the pressure angle, and this is for the gear. And then also here you can calculate, or based on the gear, and this is based on the pinion dimensions. Okay, so based on pinion parameters. Okay, and this is the same based on gear parameters, right? So we have all this information now. So we can just simply calculate the length of approach. It's going to be 25.67, the length of recess. So this is Okay, and you see they are quite close, but they are different. And then based on that, we can calculate the maximum sliding velocity. So Vs is the maximum sliding velocity, is omega for the pinion, plus omega, capital omega for the gear, and then multiplied by this distance. And I said, this distance here, you go here, compare these two values and choose the higher one. So in this case, 25.67 is larger than 21.13. So we're going to use PC as 25.67. So if you substitute these values, it gives you here the sliding velocity, or the maximum sliding velocity. Okay. So the arc of contact can be calculated as follows. So the length of contact, LAB, is equal to these two values that we have just calculated. You add them together, so this gives you 46.8. Then the arc of contact, QAR, so it is equal to the length of contact, LAP, divided by cosine phi, and this gives you 49.8. And then we need this value to calculate the contact ratio. Okay, so the contact ratio here is equal to the arc of contact divided by the circular pitch. So the circular pitch is pi d over t, or if you have the module, you just say pi multiplied by the module. But here we have the diameter of the gear, the pitch circle of the gear, the number of teeth of the number of teeth of the gear, and then this gives you the circular pitch. From here, if you use this value, substitute this value here, so this gives you the value of the CR, or the contact ratio, which is 1.585.